Hello everyone, in this work I will present to you the structural, electronic and magnetic properties of CSM and SE Half-Hazler. So, in this first step I present summary to you, which is contained the introduction, calculation method, result and discussion, and finally the conclusion. Introduction. Half-Hazler succeeds in presenting alloys by X2YZ for full Hazler and XYZ for half Hazler in 1903. This kind of alloys are ternary ferromagnetic intermetallic compound with a composition 211 and 111 for full Hazler and half Hazler respectively. We can present their structure by three-type arrangement of atom named type 1, 2, and 3. Hazler are among the most activity alloys today due to their better result and their application in industry. In our work, we present an abination study of CSM and SE half Hazler compound with the full potential linearized augmented plane wave method FP-LAPIV using N2K simulation code in order to study the structural, electronic and magnetic properties. CSM and SE crystallize in the cubic structure with 216 F bar for 3M space group. It's of the MgAgC1b type. Calculation method. The full potential linearized augmented plane wave method FP-LAPIV developed by the team of Schwarz and Anderson in the basis of self-consisting resolution of the Cohen-Sham equations. The space of matter is divided in two regions, a spherical region and interstitial region. In the FP-LAPIV method, it's necessary to have the continuity of the potential at the surface of Maupertuis sphere. Result and discussion. A. Structure properties. In this figure, which is front of us, represent the structure of the different type of atoms arrangements, type 1, 2, and 3. Figure 4 represents the total energy variation as a function of volume. We can see that the curve of ferromagnetic of type 1 have the lowest energy. For that we can say that is present the most stable state according to table 1. B. Electronic properties. I calculate the band structure of the most stable state ferromagnetic type 1 and also the electronic state density, which with these two results calculated by consideration of spin, a self-consistent filed SCF calculation was made in order to use it to demonstrate the energy of Fermi level and the energy gap, and also to know the contribution of orbital in the valence band and the conduction band. C. Magnetic properties. Using the table 2 and figure 7, 8, 9 and also 10, we can clearly see that the most stable state is type 1 ferromagnetic of CSM and SE compound. A self-consistent filed calculation was made in order to obtain the value of the magnetic moment of this state, which represent in table 2. The CSM and SE compound exhibits a high total magnetic moment, 5.9, compared to the other half Hazler compounds. Finally, we have conclusion. In this work, we present an ab initio calculation of structural, electronic, and magnetic properties by three types of atom arrangement of CSM and SE compound. These compounds crystallize in the cubic structure with the space group F43M in order of C1b. The result found provide to us that type 1 ferromagnetic phase is the most stable state compared to the other state study of CSM and SE compounds, and that it's characterized by semi-metal nature, because the bond structure and density of electronic state show that the spin-up channel, the compound CSM and SE behave like a metal because of the overlap of the energy band with the Fermi level, and on the other hand, the spin channel down present an energy gap on the result of the electronic properties. For this, we can say that at the minority spin channel down, the CSMN is behaving like a semiconductor. Finally, I would like to thank you for your time and your attention in my presentation. I hope to see you in next opportunities. Salam.